Hello students and friends. Welcome to my video tutorial on vector addition and subtraction. Question number 1. Consider the three vectors A, B, and C in the figure. If a fourth vector, vector D, is added to A plus B plus C, the result is 0. That is, vector A plus vector B plus vector C plus vector D is equal to 0. Questions. Find the magnitude and direction of vector D. State the direction of vector D in terms of an angle measured counterclockwise from the positive x-axis, and state in which quadrant this angle lies. So in the figure, we have the y and x axis, and we label vector A as this arrow, right? Its magnitude is 72.4 meters, and its angle is 32.0 east of north. That's the angle for vector A. Now, to the head of vector A, we draw the tail of vector B, whose magnitude is equal to 57.3 meters, and it makes an angle of 36.0 degrees south of west. There's the angle for vector B. And finally, we draw the tail of vector C to the head of vector B. Vector C has a magnitude of 17.8 meters. Its direction is due south. The sum of these three vectors is denoted by this green arrow. We label it as vector R, which is the resultant or the vector sum of vectors A, B, and C. It makes an angle theta with a vertical. So that angle is labeled angle theta. So for our solution, we first find the angles from the positive x-axis towards the positive y-axis. For vector A, the angle is simply the difference between 90.0 degrees and 32.0 degrees, and that is equal to 58.0 degrees. For vector B, it is equal to 180.0 degrees plus 36.0 degrees, or 216 degrees. And for vector C, it is simply equal to 270.0 degrees. We then calculate for the components of vector A. Its x component, ax, is equal to the product of the magnitude of vector A multiplied by cosine of the angle theta A. That is 72.4 meters multiplied by the cosine value of 58.0 degrees, and that is equal to 38.4 meters. Its y component, A sub y, is just equal to the magnitude of vector A multiplied by the sine value of angle theta A, or 72.4 meters multiplied by the sine value of 58.0 degrees, and we get as AY which is 61.4 meters. Now, the components for vector B, Bx is equal to the magnitude of vector B multiplied by cosine of the angle theta B, or 57.3 meters multiplied by cosine of 216 degrees, which gives us negative 46.4 meters, while its y component, by, which is equal to the product of the magnitude of vector B and sine of the angle theta B, or 57.3 meters times sine of the angle 216.0 degrees, and that gives us negative 33.7 meters. We now have the summary. Alright, so the given distances for vectors A, B, C is all given here in the first column, while their corresponding angles are also specified, and the x component as well as the y components of each of these vectors have been listed down in this table. Okay, so the sum of the x components of all the three vectors, okay, represented by r's of x, is equal to negative 8.0 meters, while the sum of the y components of all the vectors a, b, and c, represented by ry, is equal to 9.9 meters. Since these two components, okay, make an angle of 90 degrees with each other, to get their sum, of course, we use the Pythagorean formula. And that sum is equal to big R. That is equal to the square root of the square of Rx, which is negative 8.0 meter. So square of that, then plus the square of Ry, which is 9.9 meters. And what we will get is a value for the resultant, or the magnitude of the resultant vector, equal to 12.7 meters. Now this resultant vector makes an angle theta with a vertical, and the angle theta can be determined using the inverse of the tangent, or arctan. We just get the ratio of Ry over Rx. That is arctan multiplied by 9.9 meters divided by negative 8.0 meters, and we shall get the value for the angle theta equal to negative 51 degrees. We say that this angle, negative 51 degrees, okay, if you're going to check the vector diagram earlier presented, okay, this actually means that the actual angle theta can be determined by just adding 180 degrees plus negative 51 degrees, or an angle equal to 129 degrees. The actual angle is understood to be drawn from the positive x-axis in counterclockwise direction. So 129 degrees can also be written as 39 degrees west of north. Alright, to emphasize, we have the sum of the three vectors A plus B plus C, represented by vector R, whose angle theta is 39 degrees. Now, this value of R, 12.7 meters, as shown in the original vector diagram, the green arrow that we have here is what represents this resultant vector capital R. And it makes an angle of 39 degrees. That angle there is with respect to the positive y-axis. So that can also be read as 39 degrees west of north. The question is, what must be vector D so that when vector R is added to vector D, the sum must be equal to 0. In other words, we may also say, what is the equilibrant of vector R? Okay? When we say equilibrant, we are just referring to the opposite vector whose magnitude is equal to the resultant vector but opposite in direction. So we call it equilibrant. That is, if we add the resultant vector and the equilibrant vector, the answer must be equal to 0. In the diagram, we earlier noted that the green arrow in the original figure represents the vector R. So we again redraw it here. The red arrow now is what represents the vector R. Alright, what is the vector that is opposite to that red arrow? It is represented by the broken arrow here. Right? And that exactly is the equilibrant vector D. So if vector R is equal to 12.7 meters, the magnitude of our equilibrant vector D must also be equal to 12.7 meters. And what is the opposite angle? Alright, what is the opposite angle of 39 degrees west of north? Okay, little analysis of your geometry, alright, will tell you that this angle here, right, that angle is the opposite vertical angle to 39 degrees. Alright, so if you're going to use the same angle, 39 degrees, that means vector D also has a direction 39 degrees, but it is east of south. Alright, to the right of our south geographic direction, alright, 39 degrees east of south. That's what we mean by 39 degrees. So that's exactly the angle that we are looking for. Alright? Or the direction that we want to use in describing vector D, which is the equilibrant vector, which when added to vector R will make our summation equal to 0. The other question is that 39 degrees is in fact how many degrees when measured from the positive x-axis. Alright, so we know that from 0 or from negative or positive x-axis, you go counterclockwise. Okay, upon reaching this south or the negative y-axis, you exactly have what, 270 degrees. And if you add 270 plus 39 degrees, what you get in fact is 309 degrees. Where is this angle? It is an angle that lies, of course, in the fourth quadrant. Question number 2. Two displacement vectors, vector P and vector Q, have their magnitudes P equals 3 meters and Q equals 4 meters. Which of the following could be possible answers for the vector difference vector P minus vector Q? We expect one or more answers. So these are the options. Letter A 9 meters, letter B 7 meters, letter C 5 meters, letter D 1 meter, letter E 0 meter, and letter F negative 1 meter. For our solution, we base it from the definition of vector difference. When you say vector P minus vector Q, it's also the same as vector P plus the opposite of vector Q. Right? So our first case is when the two vectors are both positive. So that when we get the difference P minus Q, or 3 meters plus negative 4 meters, we will get as our answer negative 1 meter. Still, another possible case is when vector P is negative, right? But vector Q is positive, so we have negative 3 meter plus negative 4 meters, and that gives us negative 7 meters. Our third example is when vector P is positive but vector Q is negative. So when we subtract P minus Q, we get 3 meters plus 4 meters, or that is equal to 7 meters. Still, another possible case is if vector P is negative 3 meters, but vector Q is negative 4 meters. So when you subtract P minus Q, that gives us negative 3 meters plus the negative of negative 4, which is positive 4, of course. So the answer is positive 1 meter. And when the two vectors, regardless of their sign, makes a 90-degree angle, or when they are perpendicular. So we use the Pythagorean formula. We just add the square of each vector, that is 3 meters square plus 4 meters square, regardless of their signs, whether negative or positive. The result will be 5 meters. In case you're wondering why there are many possible answers to this question, it is because the given vectors only specify their respective magnitudes. There are no specific directions or algebraic signs given to P and Q. Consequently, okay, we came up with different answers. So, in general, we say that when two vectors are added, their vector sum are said to be maximum if they are in the same direction. Okay? And their sum would be a minimum if they are in the opposite directions. So, to finally summarize our answers for this question, we say that, all right, the correct answers are letter B, 7 meters, letter C, 5 meters, letter D, 1 meter, and letter F, negative 1 meter. The two options, letter A, which is 9 meters, and option E, which is 0 meter, are not possible answers. All right? Because according to our concept here, okay, the maximum possible answer is only positive 7 meters. All right? And that is letter B. All answers greater than 7 meters, that includes 9 meter, is not a possible answer. And the minimum, of course, if the two vectors are in the opposite direction. So, whichever is negative between P and Q, for example, if P is negative 3 meters while Q is positive 4 meters, okay, and using this concept, okay, the only possible value minimum, okay, is negative 1 meter. It cannot be letter E or 0 meter simply because the magnitudes of the two given vectors, 3 meters and 4 meters, when added vectorially, okay, regardless of the direction, will never be equal to 0 meter. Thank you very much for watching. Please follow me in my FB page and please don't forget to subscribe to my YouTube channel.